All right. So unfortunately for you all, there's a lot of content in this talk too. So I was going to go through it quickly, but now I'm going to go through it really quickly. So I'm Todd, Underwood, and I work for Renesys, which is a company that does routing analysis stuff. And we look at these things from layer 3. So one of the great things that Sylvie did was give you a really good layer 1 perspective, which is something I don't personally know anything about, and I thought it was cool to see the undersea cables and see more about the detailed routes that exist in the Luzon Straits. What we do is we observe this from the layer 3 perspective. So we have a bunch of, well, I'll go into where we get our data and how that looks. So the overview, you guys know, there was a quake. People were on vacation for the last 30 days. Some bad stuff happened, and you'll hear more about it. So we're going to look at this all from the perspective of the internet routing tables. The thing I'll say about this presentation is that it's very, very dense, and I'm going to skim through it very, very quickly. And you'll see things in there. If you have any assets in the region or you operate networks with people who do, you'll see things in there that you want to look at in more detail. It's all on the website, presumably, and you can go in and dig in and come find me and ask me questions later. So there's a bunch of cables. Sylvie already covered this. Complete repairs for this, maybe sometime in February, maybe March. Tough to say at this point. Sylvie already showed that animation, so we're not going to show it again. Oh my God. The hell is this? Come back. Okay. So let me give some definitions of the terms that I'll be using to describe this. Some of these seem commonsensical, but in groups full of smart people who run networks, it's important to be clear about what we mean. So we refer to a network outage as an outage for as when a route that previously exists is withdrawn by some large number of worldwide peers, and I'll clarify that in a little bit. If the network is unreachable, if there's no less specific route. So you can have an outage for a more specific where there's still traffic reachability because there's a covering less specific of some sort. The unstable networks, this is I don't know why this causes so much concern for people, but we refer to networks as being unstable when their metric of instability, which, and I'll explain the algorithm we use, but it's not that important. It mirrors flap dampening. So we give a network a penalty when we see updates in BGP for it. We decay that penalty over time, and we chart the scale of it to measure the instability. Charting instability, and just for occasionally people are confused by this, that doesn't mean we are flap dampening. It just means we're using the algorithm to chart instability. It also doesn't mean a lot of other people are flap dampening because many, many people don't do that anymore. But it's a useful way of charting instability. So here's the rough timeline, and Sylvie already went into this. One of the things that's interesting about this timeline, which you'll see in future slides, is that the bulk of the routing outages happened significantly after the biggest quake. And I'd be interested in seismologists who are also network engineers who understand submarine cable systems explaining that to me, because a little bit of it is puzzling. So the timeline, just going back, so there's these quakes. 1226 at 1226 was the biggest of the quakes, and then there's a number of aftershocks going on for the next several days, but most of them very quickly thereafter. The outage prefixes ramp up from about 400 into 1200 through the 7th quake. By 331 on the 27th, which was almost exactly and suspiciously, I mean, anybody who's ever done time analysis, and whenever you see something off by 60 minutes, you're like, I have committed an error in correcting daylight savings somewhere, right? But we've double-checked this, and this is in fact true. Almost exactly 60 minutes after the last quake, see a huge spike in outages going up to 4,000 prefixes disappearing off the map. About 2 hours later, a couple thousand of them come back. And then there's messy recovery over the course of the next several days, but the instability levels remain high. And here's an important point. One of the suggestions that's been made to me that I think is probably accurate is that the instability is a reasonable marker for serious congestion. That when you see people either route engineering around congestion or having so much congestion into the region that they're having BGP sessions drop, which both of which I heard anecdotes of, then you see that show up in the routing tables in the form of a higher rate of updates for the affected prefixes. So a note about data collection infrastructure. Renesys operates a peering collection infrastructure similar to that Route Views or RIPE operate, the RIPE RIS project. We've got about 165 plus peering sessions over 105 or so distinct ASNs. Some ASNs are big and have regionally different routing, and so we collect full tables from them on different continents where they have where they carry different full tables. So what we do with these routes is we get full tables from them, which is a little bit different. I know RIPE and Route Views get whatever the carrier likes to set up. So there's some full tables and there's lots of on-net routes. We get almost entirely full tables, so what they would send to a customer. And we store those for forever, and we do some real-time alarming and some other applications on top of them, but we also do these sorts of analyses with them. So Renesys has been looking at natural disasters, human disasters from the perspective of the routing tables for quite some time. This Canadian, I just said routing tables. Wow. The Canuck accent, it's invasive. So we've been looking at the way these events show up in the routing tables for quite some time. And they generally have a very distinct and very interesting signature. There's a very sharp onset, which corresponds to the thing that did the badness. And you can look at it in time and you can see, oh, look, there's badness, and I'll show you some examples. And then there's a return to baseline that covers the recovery depending on what type of accident it is or what type of disaster it is. Power outages recover fairly quickly. Natural disasters that cause damage to lots of physical infrastructure take longer. And there's usually noise in the recovery process, but not in the onset. So some of you remember in 2003 massive power outages in the US. Well, you look at that. I mean, it's just, look, power went out all at once and it goes straight up, right? Not surprising. And this is actually charted by size of prefix. But you see the shape. It's very characteristic. And you can see a sort of messy recovery, but it's fairly quick recovery of those things. And then some noise off to the side on both sides. Okay, fine. Hurricane Katrina, when it hit the US coast, this looks like it is a little bit messy in the onset, but each color is actually prefixes geolocated to one of the states. So what you actually see is a sharp onset per state. So for example, you see Louisiana in red rise sharply ahead of Mississippi in blue. In fact, because Louisiana sticks into the Gulf slightly further than Mississippi, and the hurricane hit Louisiana first. So what you see here is a compound event, but for each sub-event, for each portion of the natural disaster, it's actually a sharp onset. And it has that characteristic recovery. And here you see the long tail. In fact, some of the recovery from Katrina probably will never be done. It's hard to say for an event that scope when you're done recovering and now when you're living in a newly degraded state. The pattern for the Taiwan quakes was completely different and really interesting to us. There's a gradual increase in the number of outages but significantly after the major quake on the 26th. There's a big spike on the 27th, which is an hour after one of the aftershocks, which is sort of interesting. The recovery is incredibly noisy and continues. And the pattern was probably affected by the number of different cable systems. So we were tempted, and I think the simplistic thing to think of this as an event. But much like the Katrina situation, it's more a compound series of events. So here are outages and quakes. Outage prefixes, obeying the definition I referred to for outages previously, are in blue. And with the magnitude on the left, and the red lines are Richter scale quakes with the Richter scale on the right. So you see this sharp quakes back on the 26th, and really no significant increase right away in outages. You see 3, 4 aftershocks. After the 4th aftershock, you see a gradual increase in outages of about 800. And then you see an aftershock, and then you see a small delay, and then a huge spike in outages. So from my perspective, this is an interesting and somewhat puzzling pattern. On the 10-day, just gives you a little bit more perspective that the recovery is messy and includes events in the recovery, outage events, that are almost the scope of, certainly the scope of any of the outages that were happening during the period of Quake, so quite large. And then you see very messy recovery and a return to normal-ish levels of outages by the 31st of December. So here's the part that I'm going to skim through fairly quickly, but there's a number of ways you can divide up these outage prefixes. You can assign them to the country you think they came from, and that turns out to be interesting. You can assign them to the AS that originated them, and that turns out to be interesting. And then you can look at the edges that are affected by prefixes, and that turns out to be one of the most interesting. So I'll cover that last one at the end of the presentation. These are on the 3-day chart, outages by countries. Here, China's on the bottom in green, and this is not surprising, right? Part of the mainstream and technical press coverage about this was China. This is all about, you know, China got hit really bad here. Japan, okay, Korea, not so much. You know, China and Southeast Asia are really in trouble. And that sort of maps with what Sylvie presented. But the mainstream press, for some reason, I think because they talked to the wrong people or drew the wrong conclusions, somehow concluded that India just escaped the outages, because India's India and China's China, and they have nothing to do with each other. But of course they do. If you look at the cable paths, of course, most of the connectivity to and from India goes through off to the east, right? And so one of the points that Sylvie was making, which is exactly right, is that the major bandwidth into the subcontinent market and Southeast Asian markets in terms of, you know, Singapore, Thailand, is all heading east, not heading west. And, you know, this is historical accident from the development of the internet and the fact that the US is clearly the center of the world. But aside from that, it is possible, even though the US is the center of the world, to build cables that don't go to the US, and people have recently remembered this and are deciding to build some other cable systems, and this is good. So the reason we present this, this chart going back for a second is that you see that, you know, Indonesia, India have significant outages here, Hong Kong, of course. One of the questions I got going over an earlier version of this presentation is, what about Taiwan? Wasn't this a quake that hit Taiwan? And Taiwan and Taiwanese prefixes don't show up as being among the largest, either by percentage of country prefixes or by total count of prefixes in any of the charts we did. And I think there's two explanations for that. One is maybe we just have mediocre geolocation, that there's a lot of prefixes that are deployed in Taiwan that aren't registered to Taiwan, that we don't geolocate to Taiwan. So that's clearly part of it. But the second part of it is that Taiwan had a significant amount of connectivity heading north, off the north part of Taiwan. The problem was everything south and east and south and west of Taiwan. So a lot of prefixes in Taiwan were not, in fact, significantly impacted. The same chart, but 10-day. And you can see in the 10-day some significant, although during the event, Indonesia wasn't as seriously impacted. After the 27th, the pink towards the bottom, or magenta, I'm sure that's actually magenta, gets quite a bit larger in volume. So interesting stuff. Looking at one of the things we wanted to do was just zoom in on that big 4K prefix peak and say, okay, there's 4,000 prefixes out. What the heck are they? Well, they're China, you know, of course, in green, and you know, you have India in blue, and that's significant, and a little bit of Indonesia, and a chunk of Hong Kong, and you know, this is sort of what you would expect. These are the countries that are impacted in the region. The only thing that we saw that was surprising, just because the press had got it so wrong, was that India was substantially impacted, and we sort of double-checked and talked to people who operate networks in the region, and of course, that was in fact the case. Outages by Origin ASN. So again, charted for the 3-day period. Who's originating these prefixes that are going out? And here you see two things. One is you see, you know, these are by ASN, and you see Indian networks are some of the earliest impacted. But the other is, one of the things that was troubling to us is that onset was gradual and rough, right? I had talked about the characteristic pattern of this sort of outage being sharp. And when we looked at the graphs, nothing sharp about it. But when you start to break it down by country, and you start to break it down by origin AS, then you start to see the sharp pattern. So here, for example, you see a messy, rough onset, but it's not rough when you break it down by origin AS. These are individual networks suffering individual outages that stacked together form a very rough pattern going up. But individually, each of them is a sharp onset. And this gave us a little bit more warm fuzzies that we were looking at good data, and this does follow the characteristic pattern. The same perspective in the 10-day. And one of the things you see in the 10-day pattern is that after the bulk of the outages, this big other, this sort of, you know, I want to say yellow, but it's probably goldenrod, sort of a color there, just gets larger. And so what that means is that there were a few big people hit significantly early on, and then the damage spread to everyone throughout the region, presumably as people started buying and stealing transit from each other and finding any way out of East Asia and Southeast Asia that they could. Outages by Origin ASN at the peak. And it's as you would expect, although I think it's much higher prevalence of Indian ASs than people thought. So I want to show some instability metrics. The instability algorithm we used was described in a previous paper we gave. It's basically flap dampening where you know, as I said, you assign a penalty and then you decay that penalty over time. And it's a useful way of tracking the level of stability for a prefix. Here you see significant increase in instability for prefixes. The spike is not surprising because one of the things that happens when prefixes are fully withdrawn is that they go through all of the backup paths, each of which is an announcement. So if there are, you know, if I'm aware of 15 ways to get to a prefix and the prefix is completely withdrawn, I'm going to get 15 announcements for each of those backup paths before I finally get the withdrawal and say, look, there's nothing left, it's gone. So you do see when you see significant outages. And the instability patterns track roughly with the outage patterns. When you break them down by country, they track to some extent, although Indonesia crops up as having significantly higher instability. So Indonesia was previously showing up as sort of a significant but not the main story in terms of outages, but now in terms of instability, they're one of the major players here. Again, looking through the peak, we look through the, when I say look through the peak, this obviously isn't a single peak. But this is the period of time that had that peak of outages, the 4,000 prefixes that were out. And you look at the instability by that peak, and you can see who contributed to the significant amount of updates during that period. Unstables broken down by Origin ASN. I'll let you guys look through these, including the peak. So everybody loves a who won and who lost set of stories. So this is probably the part of this presentation that people are most interested in. This is the who won and who lost and interesting anecdotes. And I know that's really what people want as opposed to the data. So we use this, this metric, which is the maximum number of outages divided by the median number of outages during the time period. And the reason that's interesting is that there is an underlying level of outages in the time period that we looked at, which was from the 25th of December through the 15th of January. So it's a good solid time period. And we figured the ratio of the maximum instantaneous outage divided by the median would give you a good ratio of who was most significantly impacted. So not surprisingly, China and Hong Kong in the region were most significantly impacted. Korea, Japan, and Malaysia were least. We break down this ratio here by country, so the max divided by median, and you see Hong Kong, Taiwan, Indonesia as being the most seriously impacted and scrolling down. And maximum divided by median instabilities, here China stands out as just having, when looking at the maximum number of prefixes that are unstable with an instability metric of 3 or higher, divided by the median, in that China is head and shoulders above the rest. Now this is not corrected for, this is a count of prefixes, not a percentage originated by that country. So one argument here is, okay, well, China, you know, has a lot more prefixes than a lot of these countries. So, impacted ASNs. Some of the biggest stories were ASNs, and I sort of know a lot of ASNs just off the top of my head from doing this for a while, but a lot of these ASNs I just didn't know, I wasn't familiar with, to have such significant impact. So, you know, China Telecom was obviously seriously impacted, not surprising. SIFI in India, huge impact. VSNL, Sylvie talked about significant impact, Bharti, and so on. So these are listed here. Winners and losers by ASN. This is by number of prefixes and then corrected for percentage of total prefixes. So I think what's interesting about this is the story here I think is more on the right than it is on the left. So on the left you see, okay, so China Telecom, really significant impact, huge numbers of prefixes that were impacted by this event, you know, over 1,000. But once it's corrected for percentage of prefixes originated or transited, well, now all of a sudden, you know, it's just within the range. So this was a broad regional event, and pretty much everybody got screwed one way or another. You're not supposed to say that in public, I'm sorry. So here's the edge analysis, and this is the stuff I find most interesting. So when I refer to an edge, you know, again, this is Renesys, so we think in terms of the autonomous system graph. So when I think of an edge, I refer to the adjacency between any two autonomous systems. So if you think of the internet as a hopefully fully connected graph of autonomous systems, then the edge between any two ASs can have, you know, any number of physical adjacencies, but it just refers to the routing adjacency logically between those two. So we do two things. So we track all of the prefixes on all of the edges of the internet all the time. And we calculate two metrics on those. One of them is a metric you guys are all familiar with, which is sort of carried prefixes, which is, you know, how many prefixes are carried on that edge. If you're on one side of that edge, you can think of that as how many prefixes you announce and how many prefixes that person announces to you once you go through the route selection process and actually choose to use some of those. So that makes sense. The one that we calculate that gives a little bit different and interesting story is what we call PPT, which is prefix by peer by time. So again, we've got these 160 odd peering sessions, and we're storing every routing update for all time, and there's prefixes carried on these events. So what we do is we multiply each prefix by the number of peers who selected that prefix on that edge by the number of seconds it was carried on that edge. And it gives you a metric of the overall weight of that edge. The good thing is that can distinguish between, oh, you know, this is a peer who has transit from Sprint and sees the whole internet through Sprint. That's going to look on a prefixes perspective like, oh, here's an edge that carries, you know, whatever, 209,000 prefixes. But when you look at it in PPT, you're going to see that almost nobody selects almost any of those prefixes for any significant period of time, and all of a sudden it becomes a minor edge again. The two caveats here are that you cannot, all prefixes have the same weight. So at this point, we're not going to correct for the difference between carrying a /11 and carrying a /24. They're just a prefix for now. And you still get interesting results, although there's some degenerate cases. And then the other is that you can't tell exactly the difference between an edge that has a few peers seeing an enormous number of prefixes versus an edge that sees a small number of my peers seeing a medium-sized number of prefixes. Those will even out. So it's important to look at the two metrics at the same time. So for each edge, we generate a time series with a range, you know, as I said, from the 25th of June to the 15th of January, an 8-hour resolution, just for graphing purposes. We only considered prefixes from Southeast Asia and the Indian subcontinent. We filtered out all edges seen by fewer than 20 peers, not because those aren't interesting, but because they're probably not globally significant. If you've got 165, you know, monitoring sources and only, you know, 19 of them view a particular adjacency, we just threw it out. And then we evaluated the time series using the 2-day median difference between the end and the beginning. So top edge winners. These are edges on the internet that saw significant increase in the weight of them by this PPT metric. So what that means is either significantly more prefixes or significantly more peers selecting more prefixes for more time. And here the thing that stands out is Sprint it picks up quite a few prefixes to Bharti, 94, 98, I believe that is. But the real story, which isn't surprising given the geography of the situation, is that large and very large European carriers pick up significant transit into the region, not surprisingly. So if you are a medium-sized or large European network like, say, Telecom, Italia, or Cable and Wireless, and you've sold a little bit of transit in Southeast Asia but never, you know, it hasn't been your mainstay, but you've got capacity, all of a sudden you're the best way out of Singapore and you're going to get some business. And that's in fact what happened, and we'll go through a couple examples of that. The top edge losers, interestingly, almost all of the top edge losers are out of Singapore. So because of, and I think this has to do with the fact that Singapore had some options because there was cable capacity that Singtel had that was available heading west. And so a lot of the edge losers are Singtel to US carriers or other Singapore connected ASs to US carriers and picking up additional capacity heading west. So the winning edges graphed by total PPT score, and you can go through those after the fact. The losing edges And the biggest losing edge is actually an in-region edge between Singapore and India, between Bharti and Singtel. Huge loss in edge. And my guess is that there was significant traffic on that edge, but Singtel needed the capacity to get transit out to the rest of the internet, because I can't imagine that they actually lost the ability to get to India from Singapore, given the cable maps and what what Sylvie presented. So I'm guessing they just used the capacity for something else. So here are some interesting regional stories. Singtel, China, Telecom, and we'll go through these one at a time. So here you see in each of these, and I'll only go through a couple of them in detail, but in each of these, you're going to see on the top the PPT scores, and on the bottom the number of prefixes carried on that edge. The reason that's interesting actually appears in this graph. So if you look at the red on the top and the red on the bottom, the red is the edge between Telecom Italia and Singtel. So on the top you see, well, modest PPT score, noise during the actual series of outages about the Quake, modest PPT score, and then a sharp spike, which means that a significantly larger number of peers selected more prefixes over more time, right? Basically, the edge became significantly more utilized. On the other hand, if you look at the red on the bottom, which is the number of prefixes carried on that edge, you see, well, we thought it was around 3,800 prefixes. It goes down to nothing during the event. It bumps up to 1,300 and then stabilizes just south of 2,000. So half as many prefixes, what, 5, 6 times as many peer prefix seconds selected on the edge. Well, what happened was that was a peering edge, which meant that they had all the on-net prefixes advertised, but it wasn't transit. And so only people who were only peers of mine who are downstreams of Telecom Italia or Telecom Italia themselves would have selected that edge because it was a peering edge. It was settlement-free interconnection that wasn't advertised to all the other transits. Once you start propagating that edge as transit, they clearly agreed to accept fewer prefixes, presumably for capacity reasons, that they couldn't take all of the traffic that they would get if they would accept all of Singtel's on-net prefixes, but a significantly larger amount of traffic. And so here we see PPT as a reasonable stand-in for traffic. Other stories in here mirror similar sorts of events. So let's see. Yeah, so the cable and wireless, Singtel really edge appears from basically nothing, comes up with a small number of prefixes, but a significant amount of PPT, of pure prefix time. So interesting stories there. China Telecom, noisy and interesting. The biggest story that we saw that is mentioned in here is that the edge between China Telecom and Sprint goes to basically nothing. And now the best path to China Telecom from Sprint turns out to be through Chunghwa and HiNet. What's odd to me is, and I don't understand sort of sometimes the routing dynamics of this, but here you see sort of people doing layer 3 routing things for what I would expect to be sort of more of a layer 1 capacity issue, that they find someone with routing capacity and they announce the routes that way, perhaps because it's the easiest way to recover from the outage. But that's the significant China Telecom event as we see it. Further, I'll skim through these and you can look at these in your own time. Indosat, hugely impacted, enormously messy and complicated and interesting story, but there's no time for it here, darn it. Same with Thailand, very interesting event going on. Again, cable and wireless, Europe picks up significant amount of transit there, as does Telecom Italia. So you see some of the European carriers who had capacity in the region showing up as significant winners in the event. Global stories, this is similar data but presented by the global carrier perspective. Here you see Sprint wins big on the Indian connection but loses significant amount of 4134 China Telecom transit. Savis, I'm trying to think, interesting story about that is the significant loss of Singtel traffic. Telecom Italia, we discussed some of the winners, the winning stories here. And again, you see overall for the biggest edges, an upward trend in the amount of peers selecting prefixes on edges, but a significant downward trend in the total number of prefixes carried on those edges. And again, that mirrors the way in which those prefixes become transit prefixes, and due to capacity reasons, I believe, they accept fewer of them but send a lot more traffic on them. Similarly with cable and wireless, you can see the difference. So there are lots of interesting anomalies during the quake. France Telecom provides temporary transit to Baharti for only less than 10 days from what we see. And that, I think, in the rumor mill and some of the anecdotes that you hear is the most interesting is just how complicated and expensive it is to come up with a temporary solution to something like this. A lot of the engineers I knew realized this was a very long-term problem right from the get-go because cable systems take a long time to repair and so many were damaged. But apparently a lot of people in management thought that this was going to get fixed in 48 or 72 hours or it would just magically go away. And so there were enormous numbers of very short-term, incredibly expensive things put into place that weren't designed to last more than a few days that people are now stuck paying for a couple months or longer. Indonesian routes moved to DTAG, another interesting story. China Netcom uses Sprint temporarily and then DTAG and then drops them in favor of UUNet Transit and Savvis. And China Telecom moves routes temporarily from Savvis to Sprint. But then, as I said, now we see Sprint at some period during the event reaching China Telecom through a combination of HiNet and Tsinghua. And I guess I should have been clear. I didn't mean through one or the other. I meant through both, which is it's very odd to see an edge between two autonomous systems this large have two significantly smaller autonomous systems in the middle of a transit path. Very interesting and odd. Telecom Italia and Cable and Wireless are obviously big winners. So the conclusions are the internet's an implausible activity and it's not going to work out. And I feel sorry to have to tell you that, but you guys need to find other jobs. No. Well, maybe. I don't know. Sylvia highlighted this well, that every time something like this happens, people go into this, head scratching of what could we have done differently? And ultimately, I think realists among us know this is just about money. You can spend a lot more money and get a lot more reliability out of these cable systems. You don't have to put all the cables in the same strait south of Taiwan, but people did it for really sound reasons. They did it for the exact reasons that Sylvie laid out. You don't have to lay all the cable east, into the U.S. You can had a bunch heading west, and there are obviously economic and development reasons why people did that as well. So physical failures, the reason this event struck our interest is that physical failures are supposed to be the trivial failures that, layer 3 IP just routes around and, the mythical nuclear war development theory for IP. And the bottom line, which I think we all know, is there are obviously limits to that. And if you lose enough physical capacity, especially in markets that are growing as fast as East Asia, then you will have trouble. I think this is going to be very interesting from a routing perspective and from a business perspective looking forward into the next 5 to 10 years, because this will give rise to a renewed interest in solving some of the fundamental connectivity problems into and out of East Asia. So new cable systems, as Sylvie talked about, new interest in redundancy. So thank you. Questions? I think you have to take questions to the microphone, if there are any. Oh my God, I brought it in on time.
Todd, I'm curious, did your data suggest, maybe I heard you say this, that there seems to be a fair amount of cooperation among Asian ISPs and carriers?
Yeah, I think there's clearly that going on. From cooperation, you make it sound so nice when you say it. From my perspective, messy, complicated routing that's hard to understand. But yes, there was a lot of that.
So what little capacity did exist was able to be shared amongst the various Asian ISPs? Yeah, and you'd have to talk to an operator, but from the perspective I heard, what little capacity there was so far from being sufficient that it didn't really matter how much sharing there was. But basically, lots of stuff just didn't work. So, Randy.
Randy Bush, IIJ. I used to live in Portland. Outside of Portland's a big industrial area in a place called Beaverton. And about every 10 or 15 years, enormous costs are incurred because nobody thought Beaver Town. And where beavers live, there's serious flooding. Putting all those cables through the Luzon Strait may look cheap in the short term, but Sylvie, I'd be interested if you and others are now doing a total cost analysis and possibly a little more risk for the fisher people is a trade-off, and especially as you start, quote, heading west, following your famous Astros character or Mr. Greeley, you also might look at where you're dropping that wet glass.
A sound point. Sir.
Yeah, I had a comment based on something you said early on about the time delays. I've done geophysics in the past, and I know that undersea landslides are actually fairly slow, and undersea landslides cause most of these breakages. 50 meters a second would be a fairly fast undersea landslide. So if you think about 100 kilometers of traverse, you know, that's better part of an hour there, easily. So I think that could explain it. In fact, I would say try and correlate, well, maybe Sylvia could do this best, where the breakages are, when they occurred, and you might even see the thing just propagate along the bottom.
And my colleague Earl will feel justified because he was telling me that that was just the painfully obvious explanation, and I was being an idiot for being concerned about the gap. So thank you for...
I actually sent you a paper on that.
Yeah, thank you for convincing my coworkers that I'm dumb.
I was interested to know what's the timeline for actually the detection of the cable breaks. You had the timeline for the earthquakes and the outages. When were the actual cable breaks detected?
This is one of those, I have a sensor net of routers, not a sensor net of cable, so I don't know. And maybe there are definitely people in the audience who either operate pieces of those cables or own companies that do. So perhaps you can find some of them.
Actually, I was following up on Marshall's comment, and yours is precisely to this as well. There are, if you search hard, some published outages of the precise time and cable breakage, and they don't correlate with a major quake and then the 7 afterquakes. There is a sizable gap, and I was sort of curious as to why they weren't correlated. And then Marshall said, well, in actual fact, you don't quite expect that. You get an undersea quake moving at 50 metres per second. And then I correlate that with the map you saw, that in actual fact the cables don't sit on top of each other, they're distributed across the strait. And I believe that if you did do the geography and the timings, you could actually find which way the landslides were running. What I found was that the BGP mess wasn't tightly correlated to the precise times that the outages were reported. And there seemed to be a certain amount of keep alive, a certain amount of people hanging on to routes, and there weren't obvious spikes that precisely correlated to the noted time that the cable snapped. It was a little bit messier than that.
That's where I'm interested, not necessarily the earthquake to cable time, but cable time to BGP time.
Well, the problem is it all depends on where you are. When I'm looking in Australia seeing connectivity through AS 4637, I see an awful lot of north-south, not east-west. I saw, from my perspective, very little route outage. In other words, in my tables, I saw some attribute changes, but I didn't see withdrawals. Okay. Now, if you looked on the other side of the world, you saw withdrawals at different times and different snap events, as Todd has said. So BGP
hence our
doesn't
goal
give you,
of looking on all sides of the world all at once.
BGP doesn't give you a clean indication of an event. Depending on where you are, you see shadows of that event depending on how BGP is propagating at you. And that's what makes the BGP analysis so interesting and so confusing.
Other questions? I'll end this with a pitch. Although we have lots of peering, I don't have nearly as much East Asian peering as I'd like. So if there are people here who operate networks in East Asia or in the subcontinent or in Southeast Asia who'd like to peer with me, I would gladly accept those sessions. So thank you very much.